How to make an inlay. The edges of the inlay margins have sharper edges than those of the crowns. The smaller the mesh, the better the edge reproduction. In this example, the mesh is about 0.1 mm on a side. The Surface Wizard split the mesh into 3 parts. The outer surface of the tooth and the bottom of the model were also automatically divided. Divide the mesh at the edge that borders the outer surface of the tooth and the inner surface of the inlay. Hide the mesh on the bottom of the model and the mesh on the outer surface of the teeth. Smooth the edges of the mesh on the inner surface of the inlay with the Mesh Wizard. When dividing a mesh, color coding automatically divides it into mesh units. However, the edges of the divided mesh are bumpy at the mesh level. Smooths the uneven edges of the mesh like the edges of a surface. This can be thought of as subtly cutting away the mesh. In this example, the operation has already been completed. Although the tooth outline is not directly related to the fit of the inlay, the mesh edges of the tooth outline should also be smooth. Both the inner surface of the inlay and the tooth outline should be converted to surfaces. Unlike the example of the Zirconia frame preparation, this inlay does not have a cementation space. In a clinical case, a cementation space would be recommended. Create a fitted spline on the inside edge of the inlay. Create a 3D sketch of 10 points on the fitted spline. Set a plane at the position of the 10 points, and create a sketch. Let's look at the sketches we created. Let's look at Sketch 9. In total, we will create 10 sketches. Use these sketches to create loft surfaces. Let's take a closer look at Sketch 9. The length of the line is 0.05 mm. The loft surface is created along the inside edge of the inlay. The angle of the loft surface must be different for each part. A sketch is created using the Intersection Curves command to make the inlay connect smoothly to the tooth outline. The sketch is a tangent relationship between the cross-section of the face of the tooth outline and the line for the loft. The gray surface is the tooth outline. The dotted line in the sketch and the tooth outline surface are smoothly connected. This dotted line is related to be in a tangent relationship to the 0.05 mm straight line used in the lofting process. Create sketches of 10 locations in a similar fashion. Create lofted surfaces with 10 sketches and 3D lines along the edges. Load the loft surface you just created as a reference mesh in the mode of power surfacing and create this gray auxiliary surface. I activated the gray auxiliary surface. You can see how to create a surface like this. First, a gray auxiliary surface is created, followed by a pink foundation surface. To create the pink foundation surface, load the gray auxiliary and loft surfaces as a reference mesh. First we create the surface on top of the gray surface. Next, we will create the remaining surfaces. The pink foundation surface is now in place. Make the pink foundation surface translucent. Load into power surfacing mode. Draw a rectangle with Draw Edges, and manipulate it with the Paint Faces command to create 2 frames. This area should be filled with fine squares, and this area should be filled with coarse squares. Fill with square surfaces in this way. The rough surfaces are done by hand and the fine surfaces are created with smart fill. The occlusal plane of the inlay on the reference mesh is fitted at 10 points. Remove the fit from these points. This allows you to freely edit the surface. It also hides the referential mesh. The original surface of the inlay is ready. The surface is edited with an uneven surface, using the external surface of the tooth as a reference. The edge of the inlay should be as close to the edge of the loft surface as possible. Indent the central fossa. The edge of the inlay should be tangential to the edge of the tooth's outer surface. The original surface of the inlay is subdivided and the area around the margin is fine-tuned. It is important to note that if the lofted surface and the original surface of the inlay are not in a near-tangential continuous relationship, this will interfere with subsequent operations. Match subdivision surfaces to lofted surfaces. If the relationship between the position and shape of the subdivision surface and the loft surface is properly set up, this is a clean match. Later, we will show a bad example. Select the entire edge of the occlusal surface of the inlay. When I run the Match Edge command, I get the result shown in the image. This is due to a poor relationship between the position and shape of the edges of the subdivision surfaces and the edges of the lofted surfaces. You can revert the operation, correct the area where the error occurred, and re-execute the command to complete successfully. Solidify the inner surface of the inlay, the lofted surface and the occlusal surface of the inlay by integrating them with the knit command. The tooth outline is displayed. This is the relationship between the tooth outline and the occlusal surface of the inlay. Display to show shading. This completes the operation.